We want to talk about Abel and Jacobi's approach to elliptic integrals. So where do elliptic integrals come from? Well, they came from computations of arc lengths of curves. In this video, we're gonna give an example of how to set up this elliptic integral to compute the arc length of the Lemniscate. Then in the next video, we're gonna give some motivation for Abel and Jacobi's method of inversion. And finally, the last two videos are gonna be about Abel and Jacobi's approaches. So now let us start with computing the arc length of the Lemniscate. Let us use the following polar parametrization. Observe that by Pythagorean theorem, the square of our arc length element is just gonna be the sum of square of dx with dy. Now if we use polar coordinates, then using product rule, we can express dx and dy in terms of dr and d theta. Now plugging these expressions in here allow us to express ds squared in terms of dr and d theta. Next, we can further simplify this to get an expression involving only d theta. This is because dr d theta has a relation coming from differentiating this defining equation. Note that previously I made a typo, I forgot the square here. Now if we simplify and then square both sides, then we get an expression for d theta squared in terms of dr squared. Now plugging this back into here gives us an expression involving only r. Thus the arc length of the Lemniscate can be given by integral of the square root of this, and thus has the form integral of dr over square root of 1 minus r to the 4. So this is an example of an elliptic integral. An elliptic integral has for its integrand a rational function in the variable t together with the square root of some cubic or quartic polynomial of t. The arc length of the Lemniscate was one of the first elliptic integral to be studied. Euler and Fagnano, for examples, were interested in the problem of doubling the Lemniscate. That is, they want to ask if one knows that one arc has double the length of the other arc, then what's the relationship between these parameters? Fagnano actually showed that this A and B must be algebraically related. Euler actually proved a more general addition theorem, which says that adding this two arc length integral gives another integral of the same form, where this parameter c is algebraically dependent on this A and B. This theorem is now called Euler's algebraic addition theorem for elliptic integrals. In the next video, we're gonna see how this is just a generalization of the addition theorem for trigonometric functions.